Hello guys, good evening. You are welcome to my YouTube channel, the D.Please tutorials. As you all know, my name is Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. In today's video, we shall be looking at two questions on gas laws. If you know you have not watched the previous videos on this topic, I will advise you to do so, okay? So the first one says a gas samples occupies a volume of 2.50 liter at a pressure of 3 atmosphere and temperature of what? 300 Kelvin. Calculate the amount of gas in moles. Whenever it's this kind of question in gas laws, it tells you we are using what? Ideal gas equation. Therefore, you see from ideal gas equation, PV equals what? nRC. We are looking for what? The amount of gas in moles, which means to make n the subject formula. So this will go into this. It means that number of moles now becomes what? Number of moles becomes PV over what? RC. So let's go back to the question, which means that n becomes, the pressure given is what? 3. So 3 times, and the volume given is 2.50 over R is a constant which stands for 0.0821, then times the temperature given is what? 300 Kelvin. So that means what? 300 Kelvin. Alright, so number of moles now equals, number of moles now equals 3 times 2.50, 3 times 2.50 equals 7.5 divided by this times this. Punch calculator will be having 24.63. So this divided by this is going to be 0. Is it 0 point? Okay, 7.5 divided by 24.63, 0.305 approximately. Alright, so it means that we have 0.305 mole. Alright, take note of that. Now this number 2 is confusing. We are using the same ideal gas equation to tackle it. A certain gas sample has a volume of 800 liter, a pressure of 2.0 atmosphere, and a temperature of what? 400 Kelvin. If the volume is reduced to 4 liter and the temperature is increased to 500 Kelvin, what will be the new pressure of the gas? What will be the new pressure of the gas? So this is what we are going to do. We are using the same formula. In doing that, we'll say P1 V1 equals nRC1. It means initial pressure, initial volume, and what? Initial temperature. It means I want to look for the number of moles first. T1. So it means that number of moles now is equals what? P1 V1 over what? RC1, right? That is what it means. So number of moles becomes, the P1 from the question is the initial pressure is what? 2. While the initial volume is what? 800 liters. 800 liters. R stands for constant, which is rate. So 0.0821. 0.0821 is a constant. Then times the initial temperature given 400, right? So 400. So this times this is what? 1600. So 0.0821 times 400. I'll have 32.84. I have here 1600. So 1600 divided by 32.84 equals, 1800. I believe I'm correct here. Yes, 1600, sorry, 1600 divided by 32.84 equals, I have the number of moles is equals what? 48.72 moles. 48.72 moles. Then from here you now have it to be P2V2 equals nRC2. So divide both sides by RC. Okay? Okay, we are looking for what? The pressure now. Good. So it means we are dividing both sides by what? V2. What will be the new pressure of the gas? So V2. So P2 is equals number of moles 1000, that is 800 times 2. So it means number of moles from the initial value we have 48.72 times rate is what? 0.0821 times. It was increased, the temperature was increased to what? 500. So 500 over what is the final volume? It reduced to 4 liters. Alright, so it means 48.72 times 0.0821 times 500 equals, we have P2 as 1.999 divided by what? 4. So 1.9999 divided by 4 equals 0.4999 ATM. So this becomes our final answer. So please, this is the new pressure of the gas. Just so use this first one. You call them initials. These ones you call them finals. So after looking for the number of moles in these initials, you slot in the value of n into the finals. You have the value. Thanks for watching. Do have a wonderful day. Subscribe so that when I upload new content, you'll be notified by YouTube.